Okay. Um, Today's lesson, we're going to focus on predicting products for decomposition reactions. So again, resources that we need to have out. Periodic table, so we can look up element symbols and their charge numbers. Also, if we come across any of these diatomics, what's highlighted here, like nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen, which is off to the left. If any of these are by themselves, they exist as a pair. So it's not just H, it's H2 or N2 or O2. Okay. In addition, you're also going to want your flip chart. So like in the previous lesson where we looked at synthesis, today we're going to look at decomposition. So we'll open up our flip chart. It explains what a decomposition reaction is. It's when a single compound breaks down into two or more substances. So it's the opposite of synthesis. So we start off with a compound, AB, yields A plus B, so it breaks apart. So we have an example here of hydrogen peroxide breaks down into water and oxygen. And you can see how O, oxygen, is not just O by itself, it's O2 because it is a diatomic. The H2O, it's a compound. So only when those elements are by themselves is when we list it as a diatomic. So let's go do an example. So here we go. In decomposition, we have HGO, which is mercury and oxygen. So these two are going to break apart. All right, so we're going to list this out. We have Hg, which stands for mercury, plus, and then we have O for oxygen. Now, since O, like I said, oxygen, is a diatomic, you write it as O2. Okay? And that's all you have to do, is just separate them. Now, we have to still make sure that they are balanced. So again, just to help with balancing, some students, we can look at this and just figure it out. Others, we may have to do an inventory, which I'm going to do just in case. So on the reactant side, you have mercury, Hg. There's one of them. Oxygen. There's one of them. The product side, Hg. There's one. Oxygen. There are two. So we don't match here. We're even on. I'm sorry, it's Hg, not H. So we're even on our mercuries, 1 and 1, but our oxygens have 1 on the left and 2 on the right. Since we can't take away here, we have to add. So we have to add a 2 in this spot for the coefficient. If we put a 2 there, that 2 gets distributed to everything. So 2 times 1 mercury gives you 2. 2 times 1 oxygen gives you 2. So now we look here. Oxygens are now balanced, 2 and 2. But our mercuries are unbalanced, 2 and 1. So what number can go here? We'll put a 2, because 2 times 1 equals 2. So now we have balanced this equation. 2 mercuries, 2 mercuries, 2 oxygens, 2 oxygens. Empty spaces get a 1 as a placeholder. So there is your example on how to predict the products of a decomposition reaction and then go back and balance.